Hello, my name is Kyle Kinsler and I'm 22 years old. I'm a recent college graduate with a bachelor's degree in software development. So today what I'm going to be doing is I'm going to be doing a little video of my blockchain simulation project in its current state. Before I get into details of how it all works and how the code kind of processes and operates, I'll just give you a brief explanation of the technology stack. So for the front end, I'm using HTML, using CSS to style the entire project to make it look nice and tidy. Um, JavaScript and React. Now, I mainly chose JavaScript and React because JavaScript and React are quite popular at the moment. They always have been, but they're kind of at their peak at the moment. And I'd kind of like to enhance my front end development skills because I primarily like to work as a back end person. So I'm trying to kind of get my front end skills a little bit better. So that's why I chose JavaScript and React. In terms of the back end, my back end is currently entirely wrote in Go. Now, as the project scales, because it's still currently in development, aspects of the project might be migrated or wrote or whatever in Python. But as of right now, the code base is all in Go. There's no Python just yet. Um, as this is a blockchain simulation project, there is no database. So when you see this project in this demo, all the data is just running locally on my laptop. It's not pushing data to a database and retrieving data from a database. There is no database whatsoever. Um, before I get into the implementation details, I do have a repository for this project. Um, so feel free to have a look at the code and give me some feedback. So now I'll give you a little bit of a walkthrough through my code. So I have a package called blocks, and this is kind of the core of the project at the moment. So I have a few imports which are quite handy and quite well needed. So I'll go over this stuff here first. So we'll go over a block. So a block consists of an index. So block index 1, 2, 3. The timestamp, when was this block made, the previous hash of the last block, a transaction, and a transaction is of type transaction, which is this guy down here. So a transaction has a sender, a receiver, and an amount. Then my blockchain project is a proof of work consensus algorithm. So you need to find a hash such that you did X amount of work to find a hash. So it's not a proof of stake consensus algorithm, it's a proof of work. Then the block hash is all of this data hashed for this particular block. And then this is a new feature I worked on yesterday, and a little bit of today is a block reward, which is this struct up here. And our block reward gives miners an incentive or a reason to want to create blocks on the blockchain. Excuse me. So that kind of outlines the pipe structure that I have. Um, so I'll kind of skip over these for now, but they're fairly basic. There's just a normal transaction fee, a threshold, which we'll get to, and a slice of type block, which is for the blockchain, which again, I will get to. So if we just have a look at this function, this function creates the genesis block, and the genesis block is the first block in the blockchain. So if the length of the blockchain, which is this slice up here, if that is 0, we create a genesis block, we set up the index. I have a function called timestamp, which sets up the timestamp. The previous hash is nil because the genesis block is the first block. There's nothing prior to the genesis. An empty transaction, the proof of work, hashing the block, and then this part here is quite important. This is for the block rewards. I'll get into that function later on. This is a function call. And then we append this Genesis block to the blockchain. So that's that. The next most important part is be able to make n blocks. Now I will run this project, so I'm giving a detailed explanation of roughly how the code operates, and then I'll show you the code in execution. So we just make n blocks. So we type in, I want to make 90 blocks. The project will make 90 blocks. So we get in some user input here. We make sure we do some error handling, and then everything's all okay. We say, okay, you're creating whatever you typed in blocks. So then what happens is we loop from index 1, because the genesis is at index 0. So we go from 1 up to n. We increase the length of the blockchain slice. Keep in mind that slice is here. He was already added to here. Where is it? He was already added here on this line 70. So we get the length of the chain, we add 1 each time we go around this loop. Then I sleep. Now, you might be wondering, why would you be using time.sleep? If I remove this line of code and I wanted to make, say, 5,000 blocks, it would make those 5,000 blocks incredibly quick, even though it's running sequentially. This system does not run concurrently. Not at the moment, at least. But I have time.sleep because as you'll see, when the project is running, time.sleep kind of gives an illusion, or it simulates a block actually being constructed. Then I have the timestamp, so I'll show you this function. This is just a function call. Then another one, we get the last block hash from the chain, which we pass in that slice. And then I do some form of creating transactions. This is kind of my proof of work algorithm. Processing a transaction. Get into that function also. But here is kind of the magic of this function. If the block so we take in a block. We have a block in here. And if that block field, each block has these fields, all of these fields. And what we're saying is, okay, if this field, the proof of work field, is true, it means that we have found the hash such that a hash consists of 5 zeros. We found those 5 zeros, so we have a valid proof of work. And then we compute the block reward. Otherwise, the proof of work is false, so you didn't find a valid proof of work field. So the proof of work field is ignored, and we continue. So I just skip over that. Then each block is hashed, and then the block is added to the chain. So I'll just go over these little functions. So hash block simply just takes in all the data for a particular block. Takes in a block, and we just pass it into fmt_sprintf. Then I run a SHA-256 hashing algorithm over it to hash all that data, and then that data is returned. Timestamp is extremely simple. It simply shows the timestamp, the time in Dublin, Ireland. Get last block hash just returns the last block hash. So if we're on block 5, we're going to get the length of the chain -1, so we're going to get block 4, his hash, and put that into the current block, index 5, say. Get random string just gets a random string out of a slice. Create transaction, it's kind of Go's way of making a constructor. So it creates a transaction, and then process transaction is pretty nice. So that's that. And this function is kind of this is how my block rewards operate. So it takes in so we have a constant here called threshold. So the max amount of transactions that we can make on a normal network would be 10. And we take in counted. So if counted is greater than 10, so counted is how many transactions have we processed. And if that is greater than our threshold, I compute a new transaction fee because the network or the blockchain is getting more traffic. Otherwise, counted is less than or it's not equal to the threshold. So we just set it to be the default transaction fees, which is 0.0001, this value. Okay. Um, and then what I do is I set up the subsidy for each block, and then I compute the block reward. So that's a bit detailed, implementation details. So now what I'll do is I'll run the code and you'll see the output of the code running. So I'll do go run main. So running. Now, as you can see, I'm not running block.go because block.go is its own package. So what I have is in my directory structure, I have a main.go. So I import the package and then I just use the package when number 1 is entered. So I'll press number 1. I have a little HTTP server that loads up so that I can hit particular endpoints. So I'll just give this a second to load. So now what I'll do though, it's running locally, it's not deployed as of yet. So I'll click on follow link. So I'll have to go, it says not found, so what I need to do is, as you see, if I want to create the Genesis block, I need to go to the Genesis endpoint. I'll go to /Genesis. And as you can see, we now have a Genesis block. So the Genesis block is at index 1, the time that when the block was made, and all the other data. So then I'm going to do the next endpoint, which is mine. So I'll do mine. Now I'll come back into my terminal, and it says how many blocks do I want to make. So if I want to make, say, 30 blocks, do 30 blocks. So as you can see either the block will be made or the block will be discontinued. If the block is discontinued, that means the proof of work field is false. Therefore, that block will not be shown on the front end. If the block is like block 19 here, is made successfully, that means he has found the right value in the proof of work field, so his block will be made and pushed to the front end. So we are shown that we have made 30 blocks. And if I go back here, we can see some JSON. This JSON is not particularly nice. So what I'll do is I will load up my front end. So it needs npm run dev. Now this is going to, I'll show you the code for this in a second. So as we can see, we have 4 blocks. The first block here is the Genesis block, and then these are the n other blocks. Now, as you can see, we said we wanted to make 30 blocks, but my blockchain system computes the proof of work field, and only the correct blocks that have the right proof of work field will be shown here. So out of the 30 blocks, only these 3 blocks, because this is the Genesis block, these 3 blocks were the only blocks out of the 30 blocks that were made that found the right proof of work field. All of the 27 other blocks are ignored because their proof of work field is false. So now what I'll do is I'll click into the block and I'll show you each block, the data in each block. So we can see the time and the index. the data about this is the genesis block here. And if we come down to block 2, you're going to see some pretty important information. So I'll just zoom out a small bit. So as you can see, if we look at the genesis block, here's timestamp of this and all this information, correct? And when we hash the genesis block, we got this hash. But if we look at the second block, index 2, if we look at the previous hash field, the previous hash contains the previous hash of the genesis block. Okay, which is very important in a blockchain system. And then the sender of this transaction is this address. This address is just randomized. And the receiver of the receiver is going to be this address. Again, it's randomized. And this is just a random value. It's not actual currency being sent. And if you look at the next block, what happens is the sender was this, the receiver was this. And the next block around, the receiver becomes the next sender. So 109, it starts with, ends in AB43. And if you look back up here, it starts 109, AB43. So that block has been brought down. And then this block is hashed. So block 2 is hashed. And then in the next block, block 3, he has that hash in his field. And as we can see arrows pointing down to each block. Now, another thing I'd like to outline is that all of this is available on my README in the GitHub account, on my repository. The images aren't entirely clear because I worked on the code as of today and yesterday. But most of the code is all updated, just the README is not as up to date in terms of images. One last thing I'd like to bring your attention to, as you can see, I have the arrow in the block, which is not entirely correct. So what I wanted to have is have all this data and then have the arrow outside of the block. But if I go into my React code, this is for my front end. Just pull this down. I have some basic React code that just returns a singular component. But due to the design of React, I simply cannot I cannot have this arrow outside this div because React is designed to return one singular component. So if I put this arrow outside that one singular component, React is going to break. It's going to cry. It's going to scream at me saying, this is wrong. You're not following what React is supposed to be like. So this could potentially change in the later stages of the project. But as of right now, the arrow is in each block, but it shouldn't be. But that's how it is currently. That constraint is mainly due to the fact of the design of React. And one last thing, as you can see, the last block does not get an arrow because he has been the last block in the blockchain that's being constructed, so he does not have an arrow. Now, if I wanted to mine again, and there was another block after block 4, he would become an arrow, he would have an arrow, and then the next block, say, wouldn't have an arrow. But if I don't mine, which I'm not going to anymore, he will not have an arrow because he's the last block in the chain. There's nothing for block 4 to chain to. So I think that's a little bit of a high level, detailed explanation of my project. I hope you enjoyed. If you have any questions, please don't hesitate to contact me. And thank you very much for watching this video.